This is Jack Jackson. Today we're going to talk about some fundamental concepts in geometry and trigonometry. One of the most fundamental things that we want to do in geometry and trigonometry is to measure things. And one of the most basic things we can measure is something called length. The basic idea of length is we have a line segment like this of a particular length, a unit length. This one is 1 centimeter, so that's 1 unit length. And then what we want to do to measure length is we want to measure how many of these unit segments we can put end to end like this, and that will tell us the length of that path. So this, we could put 4 unit lengths together end to end, so this makes a path of 4 units. Okay. Now another basic object that we want to study in trigonometry and geometry is a circle. The definition of a circle is a set of points in a plane that are a fixed distance from a given point. The fixed distance is called the radius of the circle, and the given point is called the center. So if we let this point on the left end of this line segment be the center, and we use the radius 4, then it generates this circle. So notice this circle is the set of points that you see there in green. Okay, these points here, the blue points, are the interior of the circle. Okay, and the points that are outside, the points that are currently in white out here, are the exterior of the circle. But notice the circle itself is only the green points. Okay, so that's the circle. Notice it has radius 4. So if I take any segment going from center to the circle itself, all of these segments will have the same length. Okay, that length is called the radius of the circle. Now, some people use the term radius for this line segment and for its length. Unfortunately, that's using the same word for two different things, for the set of points, which is that radial, that segment, and then also the length of that segment. I prefer to use the word radial segment for the segment and then radius for the length, but it's pretty common to use radius for both. So we see that that stays the same, and that is a circle by definition. Now, we often talk about measuring a path, and we're talking about here measuring a length in a straight line. You could do this with a ruler, yardstick, something like that. But if we had a ruler or yardstick or something like that that would bend, in other words like a tape measure, then we could measure a bent path, something like this. So this arc here, in let's give it a different color. Let's make it blue. So that blue path is also a length of 4 units. So basically we're taking this line segment here and bending it, not stretching or compressing it, but bending it along this path. And we can still get 4 of those lined up. So this blue length from this point to this point, that blue arc, is exactly the same length as this red line from here to here. So we can measure things along some curvy path of some kind that's not part of a line, just as well as measuring in a straight line. If you had to do this with yourself, how could you do it? Well, maybe you have a piece of string or something that doesn't stretch but bends. You could bend it along this path, mark it, or even take a piece of paper and follow it. Then straighten it out and measure it along with the ruler. And if you did, we would find it is 4 units long, 4 centimeters in this case. So those are things how we can measure length. Now another thing we want to measure is an angle. Now remember, an angle is the union of 2 rays with a common endpoint called the vertex. So let's look at this. Here you see 2 angles. We have angle A that's up in green at the top and angle B at the bottom in blue. Which one of these is larger? Well, I think most of you would intuitively say that the green angle is larger. Well, what does that mean? Well, it's certainly not because of the number of points, because if you look, there's the same number of points in that ray, and these two rays have the same number of points, infinitely many, and these two have the same number of points, infinitely many. So as a set of points, they're the same number of points in each one, infinitely big. So that's not it. Well, what about the size of this region right here? Well, really, they're the same size as well because they're both infinitely big. So you can't really go that way. How are we going to measure this? I mean, I think everybody would agree the green one's bigger, but what do we mean by that? Well, somebody might say, okay, well, it's the distance from one of these from here to here. But we have to be careful there because we measure from here to here. We see that the blue one's longer. Well, the problem with that, of course, is it depends on which points you pick on here. They might be closer together or further away. And, of course, they could be as close together as 0 if you pick them right here at the beginning. Or they could be, arbitrarily far away. As you go way out here, it could be infinitely big. So that's not really going to be a good way to measure things there. How could we do this? Well, what we could do is go out here a fixed distance. Go out a certain distance, say maybe along a circular path, and we can measure that distance, whatever distance it is. But if we take that same distance and this point and construct a circle with that same setting, so for example, if you did this with a compass, you could put the pointy end right here and then draw an arc right here, and just leave it the same setting, put the pointy end here at B and draw the arc. You see that the arc at B is much smaller than the one at D, and so that's how we would measure that, and we see that we get a larger angle there. So now angle A is smaller. Now it's larger as we go out here. So this is going to lead us to a method of measuring angles. So let's go ahead and go to that, how we would actually measure angles. So let me start with a measure of an angle of 0.75. And here's an angle of 0.75 radians. Now radians are the preferred way to measure angles, and let's talk about how this works. So what we do is we start and we move out 1 unit length along this side. So you end up with a radius of 1 unit going out from B to point A. So we're moving out from the vertex out along the initial side, the initial ray, 1 unit. Then we rotate that point A until we get up to the other terminal side. Well, what path does that take? Well, it's this arc right here, which is part of a circle. And then we can measure that arc length with a bent ruler, kind of like we talked about on the previous page, and that bent ruler will measure that arc length. Now, let's talk about a couple other things that are related to this. Of course, this one is 0.75, so if this is 1, this is 0.75. So we would measure an angle of size 1 would be here, so now the red arc length is the same as the orange radius, the same length. And so that would be an angle of size 1 radian. Well, what if we measure out a full circle rotation? If we take this and we take it and rotate this point a whole full circle. Okay? And we rotate it not just to here, but a full circle rotation. Well, what would that be as this point goes all the way around back to here? Well, one thing we know is no matter how big or small this circle is, if we take the circumference, that is the distance from here, and measure the distance with a tape measure all the way around to here, that's called the circumference. And then we measure its diameter, that's the distance all the way straight across the circle through the center. That's called the diameter. And we divide the circumference by the diameter here, we always get the same number. And that's a special number that we call pi. Okay, that number turns out to be an irrational number. That means it cannot be made into a fraction with where it is a ratio of integers. And that means if we make it into a decimal number, which we can do, it is a decimal number that does not terminate and it does not repeat. So as a pattern that goes on forever without it being a terminating pattern or repeating pattern. So this is what we mean by the number pi. Okay? Now, so, what do we know? Well, we know that pi is circumference divided by the diameter, but we notice that the diameter is just twice the radius. So, the diameter being this this right here, which we'll make a different color. Let's see, we'll make it purple. So that purple length is the diameter, the orange length is the radius. The radius is half as much as the diameter. Okay, so the pi is circumference divided by 2 times the radius, or the circumference is 2 pi times the radius. Now here we have a circle that has radius 1, so when we replace r by 1, we get the circumference is 2 pi. And so a rotation where we rotate all the way around the circle right back to where we started, then that point A would trace around this track a path of length 2 pi. And so we would say its radian measure, if you make a full circle rotation, is 2 pi radians. Now, what if we went a half circle? That would be going out pi radians. Let's hide the full circle, and let's look at this. We need to rotate out pi. Well, pi is about 3.14. Well, we'll say about 3.14. This will get us close. Not exactly pi, but close to it. And now that we see that we're almost a full circle, half circle rotation there, and that's a rotation of pi. Okay. Now notice that we're thinking of these as rotational angles. So now we're talking about taking a ray here, okay, and we can rotate this array. We're seeing how it follows this path around here. We can go out pi, we can go around more than pi, we can even go around more than 2 pi. We can go around, so you think of this as like a spinner. You flick it and you spin it around, and it could go around multiple times. If it's going this direction, the counterclockwise way, we call it a positive rotation. If we flick it to spin in a clockwise rotation, then it's called a negative rotation. So, in fact, you can get any real number for a measure of a rotational angle. If you want a negative measure, you flick it so that it spins in the clockwise direction. And if you want a positive, you flick it so that it spins in the positive or counterclockwise rotation. Okay. Now, radian measure is the preferred measure for angles. There is an older measure called degrees. And instead of dividing it up into measuring it this way, we say that our radians, we notice that a full circle is 2 pi radians. And if you have a angle, then that's measured in degrees, then a half circle rotation is 180 degrees, and a full circle rotation is 360 degrees. So 180 degrees is actually equal to pi. Now, by the way, if you don't put a unit on it, you mean radians. So if you say an angle measures 2, that means it measures 2 radians. Let's see how big that would be. So I can measure that and show it here. 2 radians, there we go. That's 2 radians. Okay? And so in this particular one, a degree measure of 2 radians is in fact a little over 114.59 degrees. How do we get that? We multiplied the 2 radians times 180 degrees over pi. And so you would end up with degrees. So again, what we're really doing measuring radians is we're seeing how that point rotates. Okay, so that's how we can measure an angle.